Hey guys, thanks for tuning in to another video on ForgottenWeapons.com. I'm Ian McCollum, and I think we have a pretty cool video for you today. Today, we are going to take a look at the entire history of the concept of the polymer monolithic lower receiver for the AR-15/M16. The idea of not just making the lower receiver for this rifle system out of a polymer material, but specifically the idea of integrating multiple components together to create a single part that is much stronger and thus much more suited to be made out of polymer, where the original receivers, of course, were made out of aluminum. So what we have here is the whole historical series of monolithic polymer lowers. You'll notice, of course, these integrate the pistol grip and the buttstock, which in the AR platform also means that they integrate the buffer tube. These are all integrated into a single component along with the lower receiver itself. So we're going to start with one of Colt's original experimental versions of this rifle from the late 60s, early 70s. We're then going to transition to the Cavalry Arms company, which brought the idea back to life a couple decades later. We'll go through the transition from Cavalry Arms to GWACS Armory, and then we'll cover the current iteration of this concept in KE Arms KP15. So let's get started. Let's dig right into this original Colt. So the origin of the monolithic polymer lower receiver for the AR goes all the way back to Colt. Colt, of course, bought the AR-15 patents and intellectual property from Armalite, and went about then actually producing them for the US military, got them adopted by the US military and started producing them. And by the late 60s and early 70s, Colt was kind of just like rolling in money. They had a lot of cash flow from military M16 production. And they used a bunch of this income to fund a lot of interesting R&D. So Colt in this time period was doing lots of interesting projects. They had, different types of optical setups that they were working with. There's an interesting one that I've seen where they actually integrated this gigantic laser assembly into the handguard or upper receiver. Lots of kind of exotic oddball experiments by Colt in the late 60s and early 70s, and the idea of a monolithic polymer lower receiver was one of them. Now, if you're going to make the lower out of polymer, you're doing it for three primary reasons. One is to make the final product a little bit lighter. One is to make the product, the overall component, cheaper to manufacture and easier to manufacture. This ends up being a simpler component than the conventionally assembled lower receiver with its accoutrements, because normally you would have an aluminum lower receiver like this. This one's not finished. This is just an 80% incomplete forging. And onto this, you're going to attach a pistol grip with its screw, and you're going to attach a buffer tube here for the spring and buffer, which run inside the stock. They have to go in that. You've got a plate over the end of the receiver. You've got a buttstock that has to go onto this. You've got a butt plate on the buttstock. There are a fair number of components that have to get bolted into this. And if you can replace, say, half a dozen of those components with a single piece that is made out of polymer, you can have a lot faster manufacturing time for the polymer than you would even for just manufacturing, just doing the machining operations on an aluminum lower, not even counting the additional components that you're effectively getting rid of with this unitized monolithic assembly. Now, that said, there are some concerns, some things you have to take into consideration if you're going to replace aluminum with polymer. And by the way, when I say polymer, I don't know about the exact composition of this original Colt, but everything else that we're going to look at in today's video is basically glass-filled nylon. So that's the material it was being worked with once we get to Cavalry Arms. At any rate, the primary point of weakness that you have to worry about on an AR-15 lower is going to be right here, basically at the base of the buffer tube tower. And that's because there just isn't that much cross-section here. It's going to be cut away for elements of the fire control group, and this is where, under stress, a polymer receiver will typically crack. Now, there are ways to fix that, like integrating metal components into the polymer, but if you're going to start doing that sort of thing, you kind of wonder, like, what's the point? You're losing a lot of the simplicity and the potential benefits of a true 100% polymer receiver. So what Colt did when they first looked at this was instead to integrate the pistol grip and the buttstock onto the lower receiver. What this does is, first off, it gets rid of the threaded buffer tube, which is a potential weak point if the threading is polymer and the buffer tube going into it is aluminum or steel. So you get rid of that potential weak point. You're able to add a bunch more material into this critical area to strengthen it to the point that it can be strong enough when made out of polymer to give you the same sort of service durability as a smaller profile aluminum receiver. There are some other areas that need to be reinforced, and we can see that on this Colt. To start with, the cross pin that actually holds the upper and the lower together is held in place here by a little detent, and there's a spring putting pressure on the detent from below. Now, on an aluminum receiver, that hole just gets drilled right here, and aluminum is strong enough that you can drill that hole very close to the outside edge of the receiver without having to worry about it. On polymer, that hole is close, and there's a thin enough wall that hole will break through. Over time, that's a very clear and fairly quick failure point on a polymer receiver. So what Colt did is they added this extra boss of material to give extra wall thickness to drill the detent hole that comes down right here. You can see that they've done the same sort of thing on a number of other places. The pin here for the full auto disconnector. This is an original registered transferable Colt machine gun, by the way. Also the hammer pin here. The receiver has been widened out, so you can see this extra boss there, which does not exist on the aluminum. On the aluminum one, the only extra material that has been added is here to shield the magazine release button, which interestingly they got rid of, or they didn't bother to include on the polymer receiver, and up here simply to hold the dust cover off of the lower receiver. There is a similar bit of added material around the bolt release and bolt hold open. You can see on the aluminum version we have just these small two lugs that hold a cross pin. They added a lot more amount of material there when making it out of polymer to ensure that there's enough wall thickness that the pin won't break through over time. Now the pistol grip here is molded completely into the lower assembly, the lower receiver, as is the buttstock. And the way this was manufactured was sort of like a clamshell. So it was made as a left and a right half, and the two were then welded together. And again, unfortunately, because Colt didn't keep very good records, we don't know exactly what their welding process was for this, but you can pretty clearly see there how this was manufactured. It's interesting to note that on Colt's experimental version, they didn't actually have a separate butt plate. The serrations here to give some texture to the butt of the gun are molded directly into the two halves, and then they actually added in a trap door, if I can, there we go, with a little spring and a metal tube inserted inside to actually hold a cleaning kit or other, whatever you would normally put inside the trap of a regular M16 or AR-15. So that's a neat little element. Here on the side of the receiver, we have some of Colt's original markings. So they molded in the Colt Pony and Colt AR-15. The serial number has been pretty crudely hand-scribed onto the side. The GX prefix on the serial number indicates this is government experimental. That sort of serial number was used on a lot of Colt experimental, one-off sort of prototype rifles. So there are actually two of these Colt polymer lower guns that are still known to exist. There is this particular one, and there is also one in the collection of the Institute of Military Technology. Here are our selector markings, which are pretty much normal. This is, like I said, actually a machine gun, so safe, semi, and full auto. It's kind of interesting to note that at some point the front takedown pin was replaced with a bolt and a nut. The rear takedown pin is still a detent captured pin, although it has a screw slot in it. And anyway, sadly, we don't know exactly what it was that caused these guns to be dropped from consideration at Colt. I suspect that it was material failure, that the polymer that they were using at the time was insufficient for the requirements of a rifle or possibly even a machine gun. What we'll see when we take a look at Cavalry Arms is that they initially had serious trouble with the rear end of the buttstock, the end of the buffer tube, blowing out. They were using a rifle length, Cav Arms started out using a rifle length recoil system, a rifle length buffer, and they didn't have enough material in the buttstock to withstand the repeated impact of that buffer. Now, this particular rifle also uses a rifle length buffer. We have no idea how many rounds have been fired through this particular one. If I had to place a guess on a specific cause of problems with this system as Colt made it, my guess would be that they built a couple additional ones that they used for test firing, and they either broke through the back of the buffer tube area, or impacts back there led to the receiver separating at the left-right seam. But that's just a guess. So, like I said, we only know of 2 of these that still exist today. The design would kind of go into hibernation after these experiments by Colt until approximately the year 2000. The idea made a triumphal return in the year 2000 with Cavalry Arms Company. And this was a company that was formed by a guy named Sean Nylon, who had family business experience in injection molding and mold design. He had then also enlisted in the Army and fought in the first Desert Storm as a cavalry scout. And he came back from that experience with a liking for the AR-15 M16 platform and a real appreciation for lightweight gear as a cavalry scout. And he came up with the idea of, hey, let me combine those interests with my professional experience and expertise in mold design and injection molding, and let's make this AR-15 lower out of polymer. Now, it appears that Nylon knew about the existence of Colt's prototypes, but hadn't ever actually seen one. So he put this design together himself, and as a result, we can see that he made a few mistakes that perhaps he wouldn't have had he been able to see Colt's version. So this was introduced as the Cav-15, which would retroactively become known as the Cav Arms Mark I, or Cav-15 Mark I, when they later introduced the Mark II version. So you can see on the side of the receiver here that there's no extra material added. Nylon simply took the contour and the dimensions of the standard aluminum AR lower and copied them in polymer. That's okay for general durability back here, because it does still have added material back here, where you would normally have a buffer tube attached and where you have the pistol grip attached. However, it leaves some serious weak points in the receiver, and the hole here for the safety selector is a big one. There is a very thin wall down here in the safety selector, and that would turn out to be a fairly fragile area on the Cav-15. This would also be a major problem for the detent for the takedown pins. This is a slightly later generation. On the initial Cav-15s, there was a similar hole like that, drilled right here, with a buffer and or a detent and spring for the takedown pin, and that would also prove to be very fragile. So the solution that Cavalry Arms came up with was to use basically a pin with its own built-in detent, a speed pin, as it's sometimes called. And so that is, they transitioned to use those to solve that potential problem. Note out here, we still have a very small amount of material around the bolt hold open area. Those things would be iterated over time, but in these early Cav-15s, they were not. It's also worth pointing out that these are partially screwed together. So the very first generation of the Cav-15 was held together entirely and solely by screws going through the 2 halves. That was fairly quickly updated to use sonic welding to spot weld various bits of the receiver together. You can see some of the discoloration here. This particular model is spot welded, or sonic welded in places. That was a big improvement. The original screwed together guns were really not sufficient. The other major problem that they had, which is what I alluded to when we were looking at the Colt, was that the polymer at the end of the buffer tube area was too thin and would break through after not all that much use. And the solution to this was to lengthen the entire buttstock. So this ended up with a 14.5-inch length of pull, which is actually slightly longer than an M16A2 stock. And that was required to get the guns working to give them sufficient durability mechanically, but it really was not a good solution. A lot of people wanted to cut this thing off short. There was some experimentation, in particular by owners, private customers, with cutting the back end of this off, fitting like a Delrin plug to act as a buffer at the end of the tube, and then using a carbine length buffer system in them. And that would prove to be popular enough that it would be something that Cavalry Arms would look at very seriously for its own adoption. Very, very few of these Mark I receivers still exist, because when the Mark II was introduced, Cav Arms had an option for Mark I owners to exchange their Mark I receivers for the new Mark II. Knowing the durability issues with the Mark I, that was seen as a way to minimize future customer support issues just by upgrading customers to the new version. So we are lucky to have one of these examples here to take a look at. And that brings us to 2003. It's in that year that the original Cav 15 receiver was discontinued, because at SHOT Show in 2003, the Cav 15 Mark II was introduced. And it was introduced with a whole bunch of improvements, upgrades, and cool new features. So we can see a bunch of them just looking at this right here. For one thing, the material for the fire control group pins, this whole area has been reinforced. This is very much like what Colt did originally back in the 70s. The buttstock length has been reduced from a 14.5-inch length of pole to a 13-inch length of pole. That is basically M16A1 length, and it is a much better overall length. And that was done by basically converting the system to use a carbine buffer system instead of a rifle length buffer system. Now, development or introduction of the Mark II was delayed a bit. It was originally designed to be sonic welded, as had the original version been. However, it just didn't work effectively. And so what happened is Cavalry Arms spent some time looking at other options and looking at the automotive industry and also the firearms industry, in particular the Steyr AUG, which also has a clamshell type buttstock made of similar materials. They were able to adapt a technology called linear vibration welding, which proved to be a much more effective way of connecting the left and right halves of these receiver clamshells. So with that successfully integrated into production, the Cav 15 Mark II was actually available on the market by late 2003. A couple other elements to point out here. They added a sling slot in the bottom of the stock there. There had been really no good way to mount a rear sling swivel on the original Cav 15. This was introduced during the assault weapons ban, and there was a significant interest in pistol caliber versions of the AR-15, or there was starting to be at that time. And one of the popular options was 45 caliber using grease gun magazines, US M3 submachine gun magazines. And so the Cav Arms Mark II had the magazine well relieved just a little bit right here so that it could actually fit grease gun magazines, which was cool at the time. Did lead to a couple kind of lingering technical issues. You can see there that the magazine catch is not fully supported because this material has been cut away. In fact, we can compare that. Here's the original on top and the Mark II below. So you can see this wide cutout here to accommodate the grease gun mags. And that leaves the magazine catch not entirely supported, which would cause issues for the rest of the lifespan of the Cav Arms Mark II. Cavalry Arms was doing more than just making its own receivers. It also got into manufacturing handguards and other components. Interestingly, actually, they made the Cav 15, the original and the Mark II, in a variety of colors. You could get, things like flat dark earth, OD green, and some more exotic colors, yellows, pinks. There were actually a couple very small runs of glow-in-the-dark receivers that were made of both versions, specifically for company employees. That's pretty cool. However, they were also interested in expanding their market, and Cavalry Arms was able to go into business with two other gun companies to basically produce licensed versions of the Cav 15 Mark II receiver. One of these was Sabre Defense Industries, who wanted to use the Cav Arms Mark II receiver as the basis for sort of an economy version of their rifle, which they rather humorously were naming the lightsaber, if you get that, which okay, I'll stop. The receiver itself was called the SR-15. These were manufactured by Cavalry Arms with a variance from ATF, so they're marked Sabre Defense. There was a similar deal struck with Armalite under the ownership of Mark Westrom for the M15P, P for polymer, again, to manufacture sort of an economy version of their standard rifle line. Now, in both cases, sale of these versions was actually kind of sabotaged by middle management at both companies, who were concerned that they were going to basically cannibalize sales of their high-end rifles with the option for a lower-end rifle. And Armalite in particular really kind of did a disservice to the reputation of the receiver in general with the way that they treated it. At SHOT Show, when they were displaying it, they actually put it in along with all of their airsoft guns instead of their real guns. They claimed it had a 5,000 round lifespan, which nothing of the sort was true. It obviously could go far longer. Basically, the sales staff at Armalite dramatically downplayed the viability and the quality of the gun because they were, in a very counterproductive manner, they were concerned about it cannibalizing other parts of their sales. And ultimately, Armalite would basically blow out all of their remaining Cav-15 receivers at their Camp Perry shop in a giant trash can. So none of these deals went all that well for Cavalry Arms, unfortunately for them. One interesting little visible change that took place between sort of early and mid-production receivers and late production ones was a change in how the serial number tag was attached. So by law in the United States, the serial number has to be on metal, and the way this was originally done was just with a little metal plate that was embedded in the polymer. And around 2006, ATF came out and said that this was no longer an acceptable solution, that this was too easy to remove. It would take several years to come up with a suitable alternative for ATF, and what that ended up being was a larger metal plate. You can kind of see the outline of it right there, that was much more deeply embedded in the receiver, and that was something that was considered appropriate, and so production shifted to that style. It is interesting to point out that at this same time period, other companies manufacturing polymer receivers, like in this case Glock, had the exact same issue. So early production Glocks have a serial number tag, very much like the early Cav Arms ones, that's just affixed on the outside, where they also had to transition to a much more deeply embedded, larger metal tag there. Now, overall, there is a question of, was this a successful product? Did it do what it was supposed to do? So let's talk briefly about the pros and cons. On the pro side, it absolutely was a lighter weight element than a standard lower assembly. In fact, the Cav Arms Mark II, fully kitted out with its carbine buffer system, is about 1 pound lighter than an equivalent aluminum receiver with an M16A2 stock and rifle buffer assembly. So they did reduce the weight overall. They also very much reduced the manufacturing cost. This is absolutely a cheaper and faster component to make than a standard aluminum receiver with all of its ancillary components. There were a few other sort of lingering residual problems largely based on quality control and manufacturing processes that would be encountered with Cav Arms receivers. So because it was originally developed for sonic welding and then retrofitted, redesigned to use linear vibration welding, there were a few kind of holdover issues. The most commonly encountered problems would be splitting right here at the beginning of the buffer tube and splitting at the front of the magazine well. These are where the material is in some of the thinnest areas of material that are being welded together and are under stress. The not fully supported magazine catch could potentially cause binding on magazines. The solution to that was for users to bevel the surface of the magazine catch themselves. There were lingering problems with the exact placement of the pins to hold the upper to the lower. They were never quite perfectly right in the mold, and so oftentimes the fitment on the rear pin in particular will be extremely tight. These are issues that were never really quite fully resolved. The way this manufacturing process worked is an aluminum mold was manufactured, which was then filled with polymer. This is an injection mold, and basically would spit out two halves of a receiver, which would then be welded together. Well, you can't just go and move the pinholes in a mold like that. You have to make a completely new mold, and that is a multi-$100,000 process. So these are issues that Cavalry Arms tried to adjust as best they could, but the problems would linger because there wasn't the incentive to build an entirely new, slightly more perfect mold. The one last issue that came up after the fact, really, was that the magazine catch is not always 100% reliable with Magpul PMags. That's because the PMag wasn't designed, wasn't invented until about 4 years after Cav Arms put these receivers out on the market. And because it has a polymer body, the follower, the hold open follower tab on a PMag is just slightly farther forward than on an aluminum mag, and there are issues where when you stack tolerances between the smallest PMags and the smallest magazine catches, and the placement, the exact placement of the magazine catch or the hold open in the receiver, you can have guns that don't lock open on PMags. So those are some of the downsides to the original Cav Arms receivers. Ultimately, something like 10,000 of these were manufactured between 2003 and 2010. Cavalry Arms would in fact close down in 2010 following a series of legal issues that ultimately resulted in Sean Nylon, the owner, taking a plea deal that involved surrendering the FFL to the company. So the company was given a relatively brief period to dispose of its assets, sold off its firearms, and began looking for someone to buy the molds and tooling for the Cav 15 Mark II. Late in 2011, the molds and tooling were purchased by a company called GWACS Armory LLC, that is Ground Warfare Acoustical Combat System LLC. This was a company that was actually working on developing a gunshot locator system for the military, but they had an FFL and they decided to, sort of as like a venture capital type thing, take on manufacture of the Cav Arms Mark II receiver. So they basically just bought the existing tooling from the remnants of Cavalry Arms Corporation, and they set up shop, and in 2012 they began actual production of Cav Arms Mark II receivers. And as you can see here, they were marked with the GWACS Armory name and logo and location and all that sort of stuff. We believe that about 8,000 were manufactured in total by GWACS, although I don't have specific numbers on that. I've not been able to find the numbers that they reported for annual manufacturing. Those numbers should be in the public record, but I can't find them. At any rate, I think it was about 8,000 total. And they manufactured these only for a relatively brief period until 2013. The problem was, after all of the production that had been done by Cavalry Arms, the mold tooling was starting to wear out. A good example of that is here on the butt plates of the rifle. The original Cavalry Arms was compatible with standard M16 A1 and A2 butt plates. GWACS manufacturer was not. The problem was they were basically losing definition at the very back end of the mold, and in order to fix that, they trimmed off the back section of the receiver. It's not very much, but you can see that the profile is just a little bit different back here. And then they made their own proprietary butt plate to affix. And this was basically a quality control sort of retrofit. How do we deal with a mold that's not quite working, that we can't really repair? Well, we can make it work for the time being by trimming off all of this excess bleed out material at the back end. And this would, of course, have implications for other areas like magazine fit, pin fit, and so on. So GWACS manufactured, like I said, about 8,000 by the end of 2013, and then maintained those in stock. And they were selling them on a reasonable basis, a few hundred per year, until, not to toot my own horn here, but until Carl and I over at InRange did our project What Would Stoner Do, where we utilized these, brought a bunch of attention to them to market, and that caused GWACS to sell out by the beginning of 2019. So by the beginning of 2019, all of the inventory had been depleted, and this left the company in a bit of a quandary, in that their mold tooling wasn't in a state that would allow them to manufacture more, but there was significant demand. Unfortunately, they appear to have been unable to set up any further production or to finance the manufacture of a new mold, despite repeated attempts to get some cooperation to cooperate on additional manufacturing. They pretty much disappeared out of the marketplace in 2019. Business closed up, business license lapsed, and so in an effort to find a product like this to continue the story of the monolithic polymer lower and make a new and better design, we approached KE Arms, and they thought that there was a very significant potential in this idea. And that has led to the current iteration of the idea in the KP15. You can see, of course, this has all the standard hallmarks of the monolithic polymer lower. We have the integrated pistol grip, integrated buttstock. You can see some of the reinforced material here around the fire control group. The original concept as put together by Colt. However, what KE decided to do on this was to really start from scratch. They knew about the lingering problems that the Cav15 Mark II had been plagued with, and they decided rather than try and take that and update it, it would be better to take something like a proper modern aluminum receiver. And in fact, what they specifically chose was one with a flared magazine well. This is their billet flared aluminum lower. The flared mag well is an element that adds a substantial extra cost to the manufacture of an aluminum receiver because it can't use a standard forging. You have to have an oversized forging that's kind of a special order sort of deal. But if you're going to make a polymer lower, it adds nothing at all to add that billet that flare into the mold. So taking the engineering for this flared lower receiver, they then took it to a bunch of mold design experts because they wanted this to be the most efficient, the strongest, and really the best designed product that it could be, and get away from all of the lingering issues in the Cav Arms Mark II. A lot of the improvements in the KP15 are things that are kind of behind the surface, things that you don't really see from a user perspective. And they go all the way to the very beginning of the design process where, as you may recall, I mentioned that the Cav15 Mark II was originally designed around this sonic welding process, these sort of discolorations here. And it had to be, the design was retrofitted for linear vibration welding. But it always had residual problems with potential splits over time. And the KP15 was designed from the ground up for linear vibration welding. So if you look at the top seams here, the top seam on the Cav Arms is much more visible, especially if we look back here. You can see the seam between the two parts, where on the KP15, this has been very effectively blended into a single stronger piece. For example, the KP15, as it comes out of the mold, actually includes this tab on the front of the magazine well. And that is it's a sacrificial tab there that gives a bunch of extra material space to ensure that when the front of the magazine well is vibration welded together, it's a solid weld and it's held properly in position. So the Cav Arms never had anything like that. And then of course this gets trimmed off with the rest of the mold flashing. In fact, this is an example straight out of the welder, out of the mold, and then the welder that still has all of its mold flash in it. So it's kind of cool. You can see what these things actually look like when they come out of the mold. So part of the manufacturing process is trimming off that flashing both on the outside and also on all of the inner surfaces. That took a lot of expert input from mold design techs and material specialists. There is also a specific glass-filled nylon material that the KP15 was spec'd out to use. one of the reasons that Cavalry Arms was able to make a bunch of funky different colored receivers is because they honestly were using a bunch of basically recycled random material from the mold shop that was doing the molding for them. And not surprisingly, that contributed to some of their quality and consistency issues. So from the beginning, the specifications for material and design, mold flow, making sure that the two halves are engineered, are designed such that they mate up properly for welding. All of those elements went into the base design of the KP15 and make it a substantially different animal from the original Cav Arms receiver. Now, in addition to that, we have a number of obviously very user visible improvements. The sling slot has been moved to the top of the stock instead of the bottom, which is much more useful. Has a QD slot on both sides. If someone wants to use a sling there, either a single or two or even 3-point sling, you can attach it there. The pistol grip was an element often complained about on the original Cav Arms receiver, and the pistol grip design is much more modern on the KP15. There are good, deep grasping grooves on the front and the back, as well as a nice textured section on the side of the grip. Obviously, the magazine well is flared to improve reloading. It's subtle, but the bottom of the trigger guard is bowed slightly down to give more space inside the trigger guard for use with gloves. And of course, some of the issues like the compatibility with PMags have been fully resolved because, well, the PMag was designed before this rifle instead of after it, like the Cav Arms. So you can see that there is plenty of engagement there between the bolt hold open and the follower tab on the PMag. I am often asked for examples of firearms technology that were good ideas but introduced before the technology of their time was sufficient to actually make them realistic. And I think there are a number of examples. The 1895 Lee Navy straight pull and its barrel erosion is one of them. But I think one of the best examples of that is, in fact, the monolithic polymer lower to the AR. We can see that Colt experimented with this themselves all the way back in the late 60s or early 70s. And it just wasn't, the polymer technology of that period wasn't sufficient to make this a viable rifle. But moving forward to 2019 and 2020, we have much better polymers, we have much better digital manufacturing technology, and it makes what was really a very good idea in the first place now also a totally viable firearms technology reality. So I think it's really cool to be able to see the entire history of this concept all in one place and see both what changes were made between the different iterations of this idea and also what concepts or what elements really remain the same from the very beginning with Colt to the present day with KE Arms. So hopefully you guys also enjoyed the video. Thanks for watching.